Okay, so lesson 4.5 is talking about rational functions, and this lesson actually reminds me a lot of one of the calculus lessons that we do. So this is one that will definitely follow you next year if you take calculus. So the first part is just giving you some guidelines for graph sketching. Like, what information do you really need to get a good sketch of a graph if it's this kind of a funky rational function that's not super easy to just graph with a table? Okay, so the first thing, I would definitely go to page 269 because this information is there, but I'm going to give you the basics that you need. So first of all, finding x-intercepts is important. Usually the easiest way to find that is to look at the zeros of your numerator. Or another way to think about it, so if you're looking at a graph, on a graph, x-intercepts, which are like points on the x-axis, those always have a point. Like, let's say this point is the point 1, 0. This one would probably be 2, 0, right? So the common theme here is that the y value is always 0. So one thing you can do is just plug 0 in for y and solve, and that will give you your x-intercepts. So to skip down kind of the same idea, the y-intercepts would be the same situation, except it's where x equals 0. So I always just plug 0 in for x and then solve, and that'll give you your your y-intercepts. Vertical asymptotes, that is where your denominator is 0. And I'll do a couple of examples of this, but when your denominator is 0, that's kind of a bad thing, right? That's where they say it's undefined. They have these weird issues there. So that's where your vertical asymptotes would happen. Okay, and then the last situation, horizontal asymptotes, this one is much more complicated to try to figure out. So, but I have kind of a step-by-step guide here. The first thing I want you to do is find these two variables that I'm going to give you, n and k. N is going to be the degree of your numerator, okay? And then k is the degree of your denominator, okay? So I want you to find those two degrees. So you're looking at exponents there. It's the largest exponent in there. That's the degree of each of those. Then, based off of that, if the degree of your numerator is less than the degree of your denominator, then you have y equals 0 as your horizontal asymptote, or the x-axis. Okay, so that's your horizontal asymptote. The second situation is, what if your degree of your numerator is the same as the degree of your denominator? Then, this one sounds kind of confusing, but it's not too bad. The ratio of the leading coefficients is the horizontal asymptote. Okay, so we're going to do an example of that, so don't get too bogged down with this. And then the last scenario is if the degree of your numerator is bigger than the degree of your denominator, then we really have two situations here. One situation is there's no horizontal asymptote. But I say that with caution because there is a possibility of an oblique asymptote. Oh my goodness, I can't spell. Oblique. There we go. And we're going to find that using long division. And that's the very last thing we're going to do today. Okay, so let's kind of get into the weeds here and see what this looks like. So the first thing I'm going to do really has nothing to do with this. They've already graphed it for us, and they want me to use that graph to complete these statements. So this is just some terminology. They want to make sure you know how to read this. So this says, as x approaches negative infinity, f of x approaches what? So that's how you state that. So when I look over here, they're saying as x approaches negative infinity. So as my x values go negative, 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 all the way down this way. So as the further and further I go this direction, they want to know what's happening to my y value. So up here on my y-axis, where am I? So my function on this side is right here, and this is going closer and closer to negative infinity. That means my y value is getting closer and closer to this asymptote right here, which looks to me like it's at 3, right? So my y value is getting closer and closer to 3. As x approaches positive infinity, so now we're talking this side over here as it gets closer and closer this direction. So this right here is where my function is doing that. They want to know what my f of x value is getting closer and closer to. So again, it looks to me like I'm going to continue to go up and up and up and up and up, but I'm never going to cross over this dashed line because that's an asymptote. So it looks to me like 3 again is where I'm going. Okay, they want to know this one. This has even more terminology in it. So as x approaches negative 2, and then it has this little negative sign that looks like an exponent. This is saying as x approaches negative 2 from the left, because the negative side of my graph is the left side. So they want to know as x is getting closer and closer to negative 2, which is right here, that's this asymptote, from the left-hand side. So from this side of my graph, it's getting closer and closer to negative 2, what's happening? Well, it looks to me like this is just going up and up and up and up and up forever. So if I keep looking at my y values, it looks like it keeps getting further and further up, up, up. So that tells me that this is going to infinity. This one, as I'm going towards negative 2 from the right-hand side, so from this side of my graph, here's my function. And as I get closer and closer to this dashed line, this one is going to negative infinity. Last one, as x approaches 0. Now this one gives me a number on my graph, just like these did, but it's not telling me from the left side or the right side. So what that means is this from both sides should be getting closer and closer to the same y value. Okay, so from either side, I'm looking from both sides right now. As I get closer and closer to 0, it looks like my y value is also getting closer and closer to 0. So 0, 0 is that point. That kind of makes sense. Okay, example 2 is saying use that arrow notation to describe the end behavior of the function. The end behavior of the function is like what's happening way over here and way over here. Those are my ends, which means what's going to help me with that is this horizontal asymptote. So what I'm going to do is find my horizontal asymptote. That's going to help me with this. So that means I have to go back up here to number 4. Horizontal asymptotes, what do? First thing I need to do is find the degree of my numerator and the degree of my denominator. So that's what I'm going to do first. So in this case, for me, the degree of my numerator is 0 because I don't have any variables at all. And then the degree of my denominator, which I called k, you could call it d, I guess, for denominator if you really wanted to. That one is 1. The degree is 1. So what does that tell me? That tells me that n is less than k, right? N, 0, is smaller than 1. So if I go back up here, if n is less than k, then the x-axis is my horizontal asymptote. So y equals 0. So right here, let's kind of sketch a graph of this. Move it up so you can see it. So that means right here I've got this asymptote right through there, right? So then they want to know, they want me to describe the end behavior of my graph. Well, the end behavior is it's as x approaches negative infinity and as x approaches positive infinity. I'm checking to see when it goes both directions, right? Well, what's happening to your f of x value? In this case, if I'm going closer and closer towards negative infinity this way, it looks like no matter which way I'm coming from, I'm going to get closer and closer to this asymptote, which is 0. Same thing with this one. Looks like I'm going to get closer and closer to that asymptote, but I'm never going to cross it. That's at 0. So this is my end behavior. Okay, so same thing with this one. Let's check out our numerator and our denominator. These are our degrees of each of those. The degree of my numerator in this case is a 1. The degree of my denominator in this case is also 1, which means this time n equals k. So what does that tell me? If you look up here, if n equals k, then the ratio of the leading coefficients is the horizontal asymptote. So what the heck does that mean? Here's what that means. The leading coefficient here, or the number in front of that largest degree, then that's my leading coefficient. So the leading coefficient in the numerator is -3. The leading coefficient in the denominator is 1, because there's nothing in front of that, which means -3 is where my asymptote is. So right, if I'm looking at a graph that looks kind of like this, at -3, I've got an asymptote going through there. And the same thing is going to happen that happened up here. As x approaches -infinity, my f of x value is going to get closer and closer to that asymptote. As x approaches +infinity, my f of x value is going to get closer and closer to that asymptote. So there's my end behavior. Okay, so now let's move on to where we have to do a little more identifying here. And I'm going to rip this out so that I can kind of reference that again. So I'm going to keep that there, and I'm going to look at this. So example 3 wants me to identify asymptotes. That means I have to do vertical asymptotes and horizontal asymptotes. So be careful with that. And then any holes that are in the graph. So sometimes you have these like holes where just something weird is happening. And I'm going to tell you where that happens as well. So the easiest one to deal with is the holes. If it's already factored, what you can look at is when is both the numerator and the denominator going to be 0. So if I were to set all of these equal to 0, this one right here and this one right here are the same, right? So if I put a -2 in for x, then this is going to be 0 and this is going to be 0, which makes everything 0. So if you end up with 0 over 0, that is called an indeterminate form, and that's where your holes happen. So I can go ahead and write that one down, that I'm going to have a hole in my graph at x equals -2. And a lot of times they will ask you, like, where is the actual point, right? They don't want just, like an asymptote is just x equals something or y equals something, but holes, you have to have the point. So I need to find my y value. So what I would do is go back and plug in your -2 to this function when you don't have this in there. So this and this kind of cancel each other out. So if I plug -2 in right here, -2 plus 4 is 2, and 2 times 2 is 4. So that gives me a +4 on top. On bottom, if I put a -2 right here, -2 minus 1 is -3, times 5 is -15. So -4/15 is where that y value is. So I have a hole right there. My asymptotes, my vertical asymptote is going to be fairly easy to do because you're just checking to see when is only the denominator 0. So my vertical asymptotes, I'm going to write this down. That's only going to happen when this happens, when this leftover piece right here ends up 0. So that happens when x equals 1. So I'll write it up here, a vertical asymptote at x equals 1. Okay, and then the last thing I have to do is my horizontal asymptote, which we've done a little bit of. So my horizontal asymptote in this case, I'm looking for when my degrees, when my degrees are the same, so in this case, if I multiplied this out, I would get x squared as my largest term. And if I multiplied out the bottom, I would get x squared as my largest term. So if I'm looking at this one, my n has a degree of 2, and my k also has a degree of 2. If I multiply it all out, make sure that you think about it all multiplied out. So what that tells me is that n equals k. So then I have to go back to this rule again. If n equals k, what do? I find the ratio of those leading coefficients. So in this case, my leading coefficients, if I multiply all this through, I would end up with a 2x squared and a 5x squared. So 2 over 5 would be my ratio. So that tells me that I have a horizontal asymptote. Remember, if it's horizontal, that's going to go through the y-axis, which means I have y equals, in this case, 2/5. So there's my 3 things that I needed, my asymptotes and my any holes that happen. Okay, so I will stop there and do a second video for the rest.